All right, today we're jumping into something pretty wild. A claim that there's a hidden mathematical signature woven into the very fabric of the Quran, and it all centers on one single number. So let me ask you this. What if a sacred text was more than just words on a page? What if, hiding just beneath the surface, there was a complex mathematical pattern, kind of like a digital watermark? Well, that's the core idea we're going to explore today. And that number? It's 114. Now, right off the bat, you might know that the Quran has 114 chapters, or surahs. So that makes sense. But what this analysis we're looking at suggests is that the significance of 114 goes way, way deeper than just a chapter count. So that brings us to the first big puzzle in this analysis. How do you even express the number 114, not using digits, but using only the words that are actually in the Quran itself? Well, according to the source material, there's no single word for 114 in the Quran. So the only way to get there, lexically, is to build it. You have to use the words for 100, 10, and 4, and add them together. And when you do that, when you search the entire text for every variation of the words for 4, 10, and 100, you get a very specific result, exactly 11 distinct Arabic words. Okay? So these 11 words, they're the building blocks for the very first calculation. Now, this is a really key point. We're not just adding the values 100, 10, and 4. No, this method is about analyzing the words themselves. It's about looking at their lexical properties, basically their statistical footprint throughout the entire text. So for these 11 words, the author breaks it down into 5 key data points. First, how many distinct words are there? Easy, that's 11. Then, how many total letters are in those words? After that, in how many unique chapters or surahs do they appear? And in how many unique verses? And finally, a really interesting one for Arabic. How many unique root letters, the core consonants, are used to form these words? Okay, so here's what that count turned up. We've got our 11 distinct words, right? Tally up all their letters and you get 49. It turns out they're scattered across 16 different chapters and 29 unique verses, and all of them are built from a base of just 9 distinct root letters. So now get ready for this. This is the first big aha moment in the analysis. What happens when you add all 5 of those properties together? You take the 11 words plus the 49 letters plus the 16 chapters, plus the 29 verses, and the 9 root letters. And what do you get? Exactly 114, the very number we started with. Pretty incredible, right? But wait, it doesn't stop there. Not even close. The analysis then takes a turn, away from the text itself, and into the world of pure mathematics to look at the abstract properties of the number 114. So the author highlights a really specific mathematical fact about a 114. It turns out there are exactly 6 ways, and only 6, to express it as a sum of unique squared integers. Like 2 squared plus 5 squared, that kind of thing. This specific constraint is the key to the whole next step. And here they are, those 6 unique equations. You can see, for instance, one of them is 1 squared plus 7 squared plus 8 squared. Add those up and you get 114. And according to the analysis, these are literally the only 6 combinations of unique squares that do the trick. Okay, so what's next? Well, now we look at the digits inside those equations. The author counts how many times each number, 1, 2, 3, all the way up to 10, appears across all 6 equations. Then you just multiply the number by its frequency. So as you see here, the number 2 pops up 4 times, so 2 times 4 gives us 8. And you can probably guess where this is going. When you add up all of those final products, the total, once again, comes out to exactly 114. So now we have a second, completely separate path, this one based on pure math, that leads right back to that same number. And that brings us to the final and kind of the grand finale of this whole calculation. The author now takes those numbers we just used in the square equations, 1, 2, 3, 4, 5, 6, 7, 8, and 10, and goes back to the Quranic text with them. But this time, the search is much bigger. The goal is to find every single word in the entire Quran that expresses any of those 9 numbers. So every word for 1, 2, 3, and so on, all the way to 10. As you can imagine, this final search gives us a much bigger set of data to work with. All in all, it pulls up 162 distinct words. And if we analyze this group, we find it contains 666 letters, is built from 17 distinct root letters, and is spread out over 131 verses and 50 chapters. So, using the exact same method as the very first calculation, we're going to add up these 5 new properties. We've got 162 words, plus the 666 letters they contain. We add the 17 distinct root letters, the 131 verses, and the 50 chapters, and that gives us a grand total of 1,026. And here it is, the final piece of the puzzle. That number, 1,026, might seem random at first, but it's not. It's a perfect multiple of our starting number. It is exactly 9 times 114. So let's just recap. We've walked through 3 totally separate calculations here. Each one kind of builds on the one before it, and they all circle right back to the number 1114. And that brings us to the author's ultimate conclusion. According to the author Adel ben Dali Hassen, and I'm quoting here, "This is therefore much more than a coincidence. It is a digital signature integrated into the linguistic fabric of the Quran. A signature," he says, "that's only visible when you do this kind of rigorous analysis of its words as numbers." And so that really leaves us with the big question, doesn't it? Do all these layers of numerical connections point to a deliberate, embedded code, just like the author suggests? Or are they just really interesting, fascinating patterns that naturally show up when you look at a complex text through a very specific mathematical lens? In the end, what you make of it, well, that's up to you to decide.